Hi guys, welcome to this PySpark tutorial where we will explore the concept of the broadcast join and its role in optimizing join operation. In PySpark, broadcasting small data frames can significantly improve the performance of certain types of joins. We will delve into the purpose of using broadcast join and understanding its functionality through practical examples. In PySpark, there are primarily two types of broadcast join. First, explicit broadcast join, and second, auto broadcast join. Okay, explicit broadcast join. In this type of broadcast join, you explicitly specify which data frame should be broadcast using the broadcast function, and gives you fine-grained control over which data frame to broadcast. And auto broadcast join. In autoBroadcastJoin, PySpark's optimizer automatically determine whether to use a broadcast join based on the size of the data frame and the autoBroadcastJoinThreshold configuration parameter, and simplify the process as the system automatically decide whether to broadcast the data frame. Explicit broadcast join is useful when you have a specific knowledge about your data and want to optimize the join strategy. And auto broadcast join is convenient when you prefer a hands-off approach and want PySpark to make the decision based on its optimization rules. In both cases, the goal is to optimize join performance by minimizing data shuffling when one data frame is significantly smaller than the other. The choice between explicit and auto broadcast join depends on your specific use case and preference. Okay, first we will check the auto broadcast join and then we will deal with the explicit broadcast join. In PySpark, auto broadcast join threshold is a configuration parameter that determines the threshold size for automatically deciding whether a data frame should broadcast in join operation. When performing a join in PySpark, the decision to broadcast one of the data frame is crucial for optimizing performance, especially when one data frame is significantly smaller than other. Okay, and we want to start the example. Okay, here. First of all, import necessary libraries from PySpark.sql import Spark session from PySpark.sql functions import broadcast. Okay, next step is create a Spark session. Spark equal Spark session dot builder dot app name broadcast join example and get or create, and set configuration Spark session set Spark dot configuration dot set SPark.sql.auto join threshold. Okay, and here 50 multiply 1024 multiply 1024. Okay. Threshold size is set to a specific size of in bytes. If you estimate size of the data frame is below in this threshold, okay, this parameter. The parameter is designed to automatically decide whether to use a broadcast join based on the size of the data frame. This, okay, set auto broadcast join threshold to 50 megabytes. The default value for auto broadcast join threshold is set to 10 megabytes. Okay, and next step is create a large data frame. Okay. Okay, we have created a large data frame that contains 2 columns and 3 rows. And next step, create a small data frame. A small data frame contains 2 columns, ID and category, and 2 rows. And I want to perform a broadcast join operation. Result equal large df that join. And broadcast. Okay, and a small df and set comment column. Okay, it's the ID. Okay, and when performing join, PySpark optimizer estimate the size of each data frame involved in the join. If the size of one data frame is below the threshold, it's broadcasted to all worker node, reducing the need for the data shuffling. Okay, and here I show the result that show okay, you can see. And we want to deal with the explicit broadcast join. Okay, we will create a SPark CGN and 2 data frame, a large data set and a small data set. Okay, and first of all, I create a large data set. Okay, with 2 columns and 8 rows. And second data set is a lookup data or a small data frame. Lookup data frame is smaller than large data and contain 2 column, ID and category, and 2 rows. Okay, and I want I want broadcast a small data frame. Okay, broadcast lookup df and broadcast lookup data frame. Okay, next step is perform broadcast join and regular join. Result broadcast join, okay, and equal a large data frame that's join, okay, and broadcast lookup df and specify command column id, and next result regular join equal large df that join look up df and id. And I want to display the result. Print broadcast join, okay, copy and paste. And result is join, okay, that show. And print regular join result regular join that show. Okay, you can see two result sets are same, and I want display execution plan and compare two execution plan. Okay, and here okay, that explain and result that explain. Oh, okay. Let's compare two execution plan. Okay, broadcast join execution here. Ideal when employ a broadcast hash join here is in a broadcast a smaller data frame ID 12 and value 3 to all worker nodes. Ideal when no data frame is significantly smaller, minimizing data shuffling for improved performance. Project operation here. Okay, project operation selected relevant column, ID, value, and category. Okay, you can see here. Value, efficient choice for smaller tables with a reduced data shuffling, and here. Okay, and here for regular join execution, uses sort merge join. Okay, here so and hash partition here. Hash partition boosts data frame on join keys, involve more data shuffling compared to broadcast join, suitable for scenarios with a comfortable size data frame, and project operation select relevant columns here is the ID, value, and category. Okay, and two joins have some advantages and limitation. Broadcast advantages is preferred for a small data frame, minimizing data shuffling for improved performance, and utilize broadcast hash join with the build right flag, involve single partition exchange with the executor broadcast, and limitation of it is ideally suited for scenarios where one data frame is significantly smaller. And advantages and limitation for regular join. Regular join employs the sort merge join, sorting the data before the join operation, suitable for cases with a comfortable size data frame. And limitation involves more resource intensive shuffling, preferred for larger evenly distributed tables. And consideration: both strategies involve shuffling data, but the choices depends on data frame size and data distribution. Broadcast joins excel with the small tables, while regular joins are suitable larger, evenly distributed tables. And decision factor: choice based on the data frame size and data distribution. Broadcast join are efficient for a small data frame. Regular join handle larger tables, but may involve more overhead. Okay, thank you for exploring broadcast and regular joins in PySpark with us. Understanding these execution plans and their implications will guide you in making informed decision for optimal performance in your Spark applications. Happy coding! Bye!